So this question says, a cannonball is fired from level ground towards a vertical cliff. So let's have the level ground, and here's the vertical cliff. And there's the cannon. And the cannon is fired, and it says, the cannonball has a muzzle speed of 20 meters per second, so this is 20 meters per second, and it is at 60 degrees, so that's an angle of 60 degrees elevation above the horizontal. The ball strikes the cliff after it has passed through its maximum height, so it's passed through its maximum height and it's on its way down, and the cannonball strikes the cliff 2 meters above the ground, so this here is 2 meters. Okay, so it says how far away from the cannon is the cliff, so we want to find this value here. So we say find R, and I'm only going to use either horizontal or vertical information, and in this case R is horizontal, so we're going to say find R using horizinfo. You always decide, am I going to use horizontal or vertical information to begin with? And so I make my list for horizontal information, and I see that my VI horizontally is equal to 20 cosine 60. It's positive 20 cosine 60 because it's going to the right, meters per second. And then the next thing I say is my acceleration horizontally equals 0 meters per second squared. There's no force horizontal. There's just the force of gravity. And I say my delta x, which equals r, which is what I want to find out, and I don't know it. And there's two more choices. I can try and know my final velocity, but my final velocity is the same as the initial velocity because the acceleration is 0. So that doesn't really help me. I'm going to say, let's find our delta t. I know I don't know it, but I'm just going to be guided towards that. So I say delta x is equal to vi delta t plus 1/2 a delta t squared. So delta x is what I want to find, is equal to vi, which is 20 cosine 60 times delta t. And because this acceleration is 0, that second term goes to 0, so I can ignore it. And 20 cosine 60, of course, 20 cosine 60 is equal to 10. Very nice. So delta x is equal to 10 delta t. Be very nice and easy to work out if only I knew what delta t was. So let's find out what delta t is then. So we'll put that here. I'm going to say find delta t using vert info. I already tried the horizontal and I didn't know delta t. So what I do is I go to my next possibility, which is my vertical information. And I make my list and I say VI is equal to plus 20 sine 60 meters per second. It's plus because it's upwards, and it's 20 sine 60 because of the trig. And then my A is equal to minus 10 meters per second squared. And I know my displacement, I start off at the bottom and I end up 2 meters higher, so that's plus 2 meters. And I want to find my delta time, my time interval. So I say, oh, same equation, delta x is equal to vi delta t plus 1/2 a delta t squared. So plus 2 is equal to 20 sine 60 times delta t plus 1/2 times minus 10 times delta t squared. So plus 2 is equal to 20 sine 60. 20 sine 60 is equal to 17.32 times delta t minus 5 delta t squared. That's quadratic, isn't it? So let's just rearrange this so it looks nice. So we have plus 5 delta t squared minus 17.32 delta t plus 2 is equal to 0. And if we remember some of our math from before, that's my A, and that's my B, and that's my C. And the expression I'm going to use is going to be, I'm going to use delta t is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a, which equals, I'm running out of space so I've got to be a bit careful, minus, let's call it 17.3, let's give myself a bit of a break here, minus b plus or minus the square root of 17.3 squared minus 4 times a, and a is 5 times c is 2, all over 2 times 5. So delta t, I hope I can get this fitted in, is equal to plus 17.3 plus or minus the square root of, let's do this on our calculator, it's going to be 17.3 times 17.3, there's my 17.3 squared, minus bracket, and 4 5s are 20, and 2 20s are 40. 4 5s are 20, and 2 20s are 40, yes. So that's 40. So that makes 259.3. 259.3 all over 10. So this equals plus 17.3 plus or minus second square root of 259.3, and that equals 16.1 all over 10. So that gives me two answers. I have 17.3 plus 16.1, enter, divided by 10. So I get 17.83 seconds, or I get 17.3 minus 16.1, enter, divided by 10, which is 0.12 seconds. Let me just check that first one again. 17.3 plus 16.1, enter, divided by 10, enter. Oh, sorry, yeah, I thought this was like way too big. This is 3.34 seconds. So 17.3 plus, yeah, 17, and that is about 30 odd divided by 10. Yeah, okay, 3.4 of that. Let's have a look. What's going on here? You pass this height on the way up in 0.12 seconds. So that is the time on way up, and this is the time on way down. So they both have physical meaning. But here's the point. You can take this guy and you can bring it back to there. Let's do this bit in red. So delta t is equal to 10 times 3.34 seconds. So, I'm sorry, delta x. So delta x is equal to 33.4 meters. There's your answer. So it's a classic multi-step problem. It's a lot of work, but it comes in little stages. We started off by drawing a diagram, and then we decided to try and solve it in one step, so we used the X information. We made a list of X information and pushed it as far as we could and recognized we needed time. We then decided to try to find time using the vertical information. It's all that was left to us. And we made a list of vertical information and we tried to find the time. We chose to use the quadratic expression. We figured out our quadratic expression and we ended up with two times. One time, the shorter time, represented how long it took for the projectile to reach the 2 meter above the ground mark on the way up. And the second, the longer time, represented how long it took the projectile to reach the 2 meter above the ground mark on the way down. Having chosen the correct time, we substituted back into our horizontal information equation, and we just found our displacement R. We could have chosen to solve for V final here, and then with V final we could have chosen to solve for delta t, and that would have avoided this quadratic expression, but it makes a third step. Some people like it, some people don't. The approach is very standard. You draw a diagram, you try to solve it in one step, you make a list with only one type of information. If you get your answer, hey, good. If you don't get your answer, you figure out what you need to do. You go to the other axis, you make another list, you use your kinematic equations and try and solve it. It's very standard. The approach is always the same. Sometimes you need two steps, sometimes you need one step, but the approach is always the same. So focus on the approach. Don't worry particularly about the details. I mean, do worry about them so you can do them, but this question you'll probably never see again in your life. So it's not memorizing this question that counts. It's memorizing the approach. Diagram, decide which direction, horizontal or vertical, you're going to try and find the answer. Make your list, do your best. If you can't solve it, go to the other axis. If you were horizontal, go vertical, try and solve it, substitute back in. And if you do that right, it will work every time.